my name is Rosie and I'm going to explain you one of the most useful topics in life.
Hi, my name is Paola, and I'm going to explain you a little bit about rational functions. Basically, they are a fraction but with polynomials. That means we have to have a variable and something else. Or we just can't have a variable. There are many examples. Let's go see some.
Now, to solve a rational function with two asymptotes, first, we have to factorize the equation. Second, find the horizontal asymptote. That my friend Rosie will explain in a little bit. The fourth step is to find the crosses of y, and then the crosses of x. When we have this, we can graph, and as the last step, we found the domain and range. Now, let's hear my friend Rosie.
Hi friends, I'm going to explain you how to find the horizontal asymptote. Well, you have to check the degrees first of all, and like you can see in the first case, the top degree is smaller than the below degree, so the horizontal asymptote will be in 0. In the case that they are the same, we are going to make a division between those numbers that have the same degree. In this case, the result will be 2, so your horizontal asymptote will be in 2. And the last case will be if the top degree is bigger than the small degree. In that case, you will not have horizontal asymptote.
Now, here we have our example where f of x equals x squared minus 4 over x squared minus 4. In the first step, when we factorize it, we get x plus 2 times x minus 2 over x times x minus 4. As the degree of our variables are the same and they have no coefficients, the horizontal asymptote is at y equals 1. At the step 3, to get the vertical asymptote, we equal our both terms in the denominator to 0, and we get 0 and 4. We can see them in a green dot line in the graph. Due to the fact that one of our vertical asymptotes is 0, we don't have any crosses of y. And to get the crosses of x, we have to substitute x for the values inside the vertical asymptote to see the behavior of the graph. In this case, we chose 1 and 3 because they are closer to the asymptote. We get 1 and minus 5/3. As we can see, the graph will cross the horizontal asymptote, but only at this point. To find in which plane of the graph will be the other two parts of it, we substitute x for 5 and minus 5. Even though the results are fractions, now we have the coordinates to the points, and therefore the behavior of the other graphs that we can see in step 5. The last step is to find its domain and range. The range is very easy, because as the graph crosses the horizontal asymptote, y is equal to all real numbers, and we can write it in an interval notation as minus infinite to infinite. In the domain, we just have to skip the vertical asymptotes. Therefore, we have minus infinite, 0, union 0, 4, union 4, infinite. And that's all in this example, my little friends.
The hollow point. The hollow point is, it appears in this kind of cases when you have the same value at the top and bottom. In this case, it's x plus 1, but you are going to reach for the vertical asymptotes as you usually do. In this case, the results will be x3 and x minus 1. But in the case of x minus 1, instead of being a vertical asymptote, it will be a hollow point. Why? Because you have x plus 1 and x equals 1 at the bottom and at the top. Top and bottom and top of the function. So that's why instead of being a vertical asymptote, it's a hollow point. You graph this by putting a circle on that point. In this case, we have a little purple circle on the point -1 and a normal vertical asymptote in the point 3, and you graph as you usually do.
First, we take out the horizontal asymptote. This asymptote will take out seeing the value of the x. The result of the asymptote will be 2, since the variables are the same and we have to divide the coefficients. Now we are going to remove the vertical asymptote. This asymptote will remove it by clearing the x minus 3, since it is the denominator of the rational function. The result will be x equals 3. Now let's graph the asymptotes. After having graphed the asymptotes, we will have to find the crosses of y and x. To get the first value of the crosses from, and we need to replace the x of the equation to 0. To get the other point, we will do exactly the same, only that instead of replacing with 0, we will substitute for the values we want. In this case, I choose 2. Now we graph the crosses of y. Now to take the crosses in x, substitute the x of the equation to value that is greater than 3. So we will choose 4. We repeat the step, we only substitute for 8. We graph and put denominator and range. Salma, Rosie, and Paola. We hope you enjoy it and thank you for your attention. Bye.